and then you can work some examples on your own. So one of the first things let's look at is what is standard form for a quadratic, okay? So standard form would be, for a quadratic equation, would be y equals, okay, ax squared, okay, so you want your squared term first, okay, plus bx plus c. And I know I went over it kind of over the page. And remember here, it's really important that we recognize that the a variable goes with the x squared, the squared value. The b goes with just the x to the first, and then the c is where there's not an x. C is our constant value. So get used to recognizing if I said, okay, what's our a value? You would say whichever one is attached to this x squared, okay? So let's get used to that. So what's next? Graphing. We have to graph quadratics, right? When graphed, a quadratic equation creates a U-shaped curve called a parabola, okay? Parabola. And something y'all are going to talk about a little tomorrow, okay, is when quadratics are useful for life. Like, where are some ways that quadratic equations can be found in life? So think about that. Think about what their graphs look like, and think about where we might use this in real life. So now I want you guys to go ahead. Y'all type into your calculators, if you remember how, okay? If you type into your calculators these two formulas, let's graph them. So let's start, and then I'm just going to sketch what they look like. So you'll have it, and then we'll talk about them. So this is y equals x squared plus 2x minus 5. And that's going to look similar to this, okay? And it might not be, that's not exactly right, sorry. It's going to look similar to that-ish, okay? We've got our line of symmetry here, okay? And then these go on forever, so we put arrows on them, okay? And then y equals negative x squared plus 3x plus 7, and that's going to look something like this that goes on forever with our line of symmetry down the middle, okay? So these are our two ways. If a is positive, okay, positive, then the parabola opens up, okay? So positive, it opens up like a smile, okay? So that's an easy way to remember. If a is negative, then the parabola opens down like a frown. So that's an easy way to remember if this x squared term up here is positive or negative, which way the parabola is going to open, okay? So now let's think about, and this is just an intro of these notes, thinking about the different parts of a quadratic equation. So this is thinking about the value of the x squared term. But the axis of symmetry, okay? The axis of symmetry is the vertical line that divides the parabola into two equal parts. That divides the parabola. So I was graphing that earlier and just not saying, I hadn't given the definition, into two EQ, I'm missing a U there, equal parts, okay, two equal parts. And we have a formula, okay, we have a formula that will always give us our axis of symmetry, which is awesome, and that's x equals negative b, okay, remember b, that would be the coefficient that's associated with the x value, okay, b over 2a, okay, so 2, and that's 2a, a is the coefficient associated with our x squared value, okay, so negative b divided by 2a, x equals negative b, gives us our axis of symmetry, okay, and we'll look at that more later, we'll look at a couple examples. And then our vertex, what is the vertex, okay? The vertex is the turning point of the parabola. And so I like to think of this, we're going to write that in this definition, the turning point of a parabola. But I also like to think of this as like the max or the min you can see, and so that's what this next part says. When the vertex is the lowest point, it's called a minimum. I'm just going to write min, okay, min. And when it's the highest point, okay, so if it's a negative quadratic equation, then it would be the max, either the max or the min. So let's just scroll back up real quick. In this case, this is a minimum, right? That's the vertex, this point where it changes. It's not quite right, but, and then this would be the maximum, the vertex, the point where it changes. The turning point, as they call it. So that's just an example. So let's just do this example, and then y'all can work through the rest by yourself, or if you need to help each other, you can, okay? So our graph is y equals x squared plus 8x plus 15, okay? So let's find the axis of symmetry, okay? So that would be x equals negative b, so negative 8 divided by 2a would be 2 times 1. A is just 1. In this case, we're looking, remember, a and b over here. So 2 times 1, so that equals negative 8 over 2 equals negative 4. So x equals negative 4 is our axis of symmetry. And then our vertex, in this case, is 4, negative 1. And we can know that, okay? Let's think about how we know that. Let's actually, before, I'm going to work this in the margins, okay? Work it down here. Our vertex, we can find by plugging in the x value on our axis of symmetry. So we can find the y value of our vertex by saying y, we can plug in this x equals negative 4, right? Squared plus 8 times negative 4 plus 15, okay? And so if you plug that in, you end up with y equals negative 1, okay? And so then our vertex is going to be negative 4, okay, negative 4 comma 1, x value, y value, and then now we can sketch it, okay? And what do we know? We know this parabola opens up because the x squared value is positive. So let's just do a tiny little sketch here. And 4, negative 4, 1, let's just envision negative 4, 1, 2, 3, 4, negative 4, down to 1. So that's going to be our vertex. It's that point right there. Our axis of symmetry is there. And then it's going to be exactly the same. Symmetry means it's the same on either side. So you can just kind of draw it the same, the best you can, draw the same, sketch it the same on either side. So that's just a quick sketch. This is what I want you guys to do for the rest of them, okay? Calculate your axis of symmetry, plug that in to find your vertex, and then sketch the rest. I'm going to have the answers for you on Google Drive, but don't use your calculators on this. You can use your calculators to check it, but try to do it by finding the axis of symmetry and the vertex first, and then you can check it either with my answers or with your calculator, okay? Hey guys, so this is just going to be our intro to quadratic equations, okay? And it should have been something y'all talked about last year. I don't know who has and who hasn't, but either way, this is just going to be kind of an intro until I get back. So a quadratic equation, if you remember what the word quadratic means, it's just something where we have something to the second degree, right? A polynomial to the second degree is a quadratic. So this would be an example of a quadratic. Or you could add plus x. That would still be a quadratic because 2 is your highest degree. You could have something like x squared minus 7, x squared plus 8x minus 2. There's all different types of, these are quadratic polynomials that are quadratics. What makes something an equation, right, is if we add an equal sign, okay? So just adding, or you could say equals y. There's different ways, but adding these would be quadratic equations. So now let's take a look at y'all's notes, and we're just going to kind of spend this time filling them in.